Hello, I think we're ready. My name is Vlas, and I would like to tell you about ARKit 1.5. So you may remember the last time I made a talk about AR. That was about the Reveal AR demo making off. And if you haven't seen that, you can catch it on Melbourne CocoaHeads YouTube. And basically, what I was talking about there is combining the powers of ARKit and Vision framework to interactively track a QR code effectively in the scene managed by ARKit and track its position and orientation so that we could display a sort of a fake representation of view hierarchy that's displayed on the screen of the device. That's cool and all. And back in that talk, I discussed a few limitations of ARKit back in the day and how the approach with QR code actually kind of worked around those limitations. Now, I think a month ago, iOS 11.3, is that it? Came out bundled with ARKit 1.5. And with it, it brought a few interesting things. First of all, finally, we can now detect vertical planes. That was actually something that you could see, you could have seen in the documentation for one of the first seeds of iOS 11.0, but then it was kind of silently removed. It's like, oh no, we don't actually have that. The other very interesting new feature in 1.5 is that now you can actually detect images in your scene. You can provide reference images, and ARKit will detect them in the world around you. And these two are, in my opinion, are two major features of 1.5, and there are also a few interesting minor features, I would say. For plane anchors, instead of only having access to information about the extent of the plane, the width and height, you can actually get a coarse mesh geometry. So that, for example, if the object that ARKit has detected is not a perfect plane, which it's not always, it will give you a coarse representation of the shape of that horizontal surface or vertical surface now. And you can use that to actually hit test against not the extent of the plane, but against that coarse geometry. Camera can now use autofocus mode, which is actually enabled by default for applications that link against ARKit 1.5, which is pretty useful. You can now also choose a capture format for the camera, so that, for example, if you prefer a lower resolution, you can choose that. You cannot actually specify like any values. You have to choose among the list of supported values. And for example, on my iPhone 10, I think the resolution the formats to choose were either 60 FPS Full HD or 60 FPS 720p. And you can also opt in to automatic session relocalization. So for example, if there was an interruption, maybe like an incoming phone call, but you were mostly standing around in one place, the application can now, well, ARKit can actually try to relocalize the session after this interruption. So it will try to hold on to the feature points it knows about and restore your session without having to reset everything. So a bit more about the major features. So vertical plane detection. It's back after linking. It's basically the same as horizontal plane detection, but vertical, right? Very good for IKEA app, I'm sure. And you would think that it should be good for something like walls, right? Well, there's just one little caveat. Vertical plane detection has the same kind of limitations as the horizontal plane detection, which means that if a vertical surface doesn't have enough texture to it, feature points for ARKit to grab onto, it will not actually detect it. And as you can see, most walls are actually the same color. So how exactly this could be useful for walls, I'm not sure. Maybe outside, outdoors, where maybe you have brick walls or something, absolutely. Indoors, maybe not. Reference image detection, I think it's, in my opinion, the most exciting feature of 1.5. So you can supply images, the reference images, and their real world size when starting the session in a form of either CG image, so you can effectively create those reference images in runtime, or you can just specify pre-baked images from your asset catalog. Asset catalog in Xcode 9 point whatever it's these days supports adding pre-baked reference images for ARKit. What's cool about this feature is that it actually allows you to detect images at any orientation, kinda. So it's not tied to your plane anchor. It's not tied to specifically horizontal or vertical planes. It's smart enough to actually detect images that are somewhat rotated. There are limitations, obviously. And it can also detect partial matches. So, for example, if you see, if the camera can only see, let's say, not sure about specific numbers, but let's say 80% of the reference image, it can still detect that. And as you may have seen from Apple's PR material, the primary use case, in their opinion, and that's kind of that makes sense for this feature, is, for example, showing some kind of interactive AR scene or something in front of like a painting or some exhibit in a museum. So you just, you walk around the museum, you see some image, it's actually a reference image in the app, you point at it, and it like blows up into something interesting. And yes, it will actually also update the image anchor detects if the reference image in the real world actually moves around. If it's not a static painting on the wall, if it's something that's dynamic, it will update the position and orientation. And with that, no! Technical problems. How do I do this? Okay. Let's get back to that. So, how does this all connect to the Reveal AR demo? So you may remember that it was using a QR code tracking using Vision Framework to track the screen in the world. So image detection could actually replace that in theory. And there are some pros and cons. The pros are, well, we don't need to cover the screen with a QR code, obviously. It works at reasonably, with different orientations. At a different angle, it will still detect that, while the previous demo could only work if the QR code was actually on the plane that it already detected. But unfortunately, it's also slightly, well, somewhat less reliable, just because, well, previously, Vision Framework could detect the QR code with a certain errors, effectively, with certain noise in the picture. The images are a bit more finicky. It might not pick an image right from a screen. The main problem actually there is because the screen may have a higher brightness than the surrounding world, which means that the image from the camera may be overexposed. Yes, so that would block ARKit from working. And then the position and orientation updates of the image anchor are around 1 second or maybe half a second, while if we use Vision Framework, we control how often we actually update the anchor information. And then, yes, well, you actually need an image, an up-to-date image of what you're looking for, and that image carries no actual data, while if we detect the QR code, we can actually extract some data from that QR code. So yeah, there are pros and cons. And well, let's take a look at that, how that works. So I will start with using my iPad for this purpose, and you can see once it loads that it actually works. It has detected the image. I'm enabling this debug mode, and you can see that this red rectangle is the detected image. So in this case, it actually worked pretty well, maybe because the brightness of the iPad and the surrounding lighting condition is good. So that's the image detection. I was also playing around with using the QR code itself as the reference image. Whoops. Let's put it back into its state. Yeah, I can see that the image is not highly saturated. Come on. Whoop, there you go. Oh, that's actually the original mode, just for reference though. So here's how it tracks when it's using QR code, but you can see that there's still some glitching going on. On the other hand, if we're using image detection, loading, there you go, it will still work, but it's a bit more glitchy. But on the other hand, you can see how it works under the angle. So I can rotate the iPad and it still pretty reliably detects that image. Even as the image rotated, it detected the rotation. Whoop, and it rotated itself. So that's nice. I was actually playing around with an alternative, and that is using actual printed screenshots. And you know what? It also worked. In different lighting condition, it could actually work better. There you go. Detected the image. And it still works. I should probably collapse it slightly. Well, that's kind of about it. And in terms of vertical surfaces, I'll just quickly show that we have this box. It is effectively my vertical surface, and it has detected this coarse mesh. It's obviously not very precise, but it's something. And well, not sure how well that would work. There we go. Has appeared. So obviously this white overlay shows the geometry that ARKit gave me. And I think that mostly covers the features of ARKit 1.5. I guess the outcome of that is, for me, that the QR code tracking approach, I think, still has its own uses because of those different pros and cons with image detection. But if you have something in a physical world that can be represented as a printed image or a picture, that's definitely more useful. I think that's it. Any questions? Okay, there you go.
Just to clarify, the image you're using is the full UI, that full thing, not part of that?
Well, yeah, this is just a screenshot of a Soundstagram, an app, it's an app we ship with Reveal. And yeah, it's just an example, essentially. Anyone else?
You compared ARKit with Fourier performance with target tracking.
Oh, compared with the what, sorry?
Fourier? Like AR library that helps.
Right. Okay, no, I haven't tried that. I've only tried ARKit. And by the way, speaking of which, so I've just run the ARKit for app, with 1 or 2 or 3 reference images and some extra processing. And my phone has hit it up significantly, to be honest. So, yeah, keep in mind the battery drain when working in AR. Yeah, performance can actually vary. It all depends on the lighting conditions, depends on how many feature points you have on the screen, how much you move around. But no, I haven't compared with other solutions.
So usually walls are not well lit, so how do you find that with a vertical?
So as I mentioned, I don't think walls are a good example of vertical surfaces that ARKit right now with the current hardware is good on. But maybe at some point, Apple will release a phone that actually has a LiDAR on the back that actually performs scanning of the world around it, and this way, obviously, detecting vertical surfaces would be much easier. Well, I say much easier, as if it's like not rocket science, right?
How does the code differ between the two approaches?
You mean the image reference versus the QR code? Obviously, image reference tracking is much simpler because you just specify the image itself and the physical size, and you will obviously need to handle a different kind of different kind of AR anchors, the image anchor. But apart from that, yeah, image anchors are much easier to deal with because you don't have to implement any custom code essentially. Oh, there you go.
How do you do to put like an image anchor, like some kind of like to get the pattern of the image you want to?
Now that's, I don't think that is possible right now. So essentially you need to specify a precise representation of the real world image that you would be looking for. Hopefully in ARKit 2, I'm hoping that there would be something that would allow us to use custom techniques, maybe, for example, even a marker detection technique, because I've seen that inside the framework. It's still not exposed. I'm like, okay, I'm waiting patiently. But I'm hoping that we'll be able to either somehow customize the detection, or at least we'll be able to detect the classic traditional AR markers, like something you may have seen if you were dealing with older AR libraries. Anyone else?
File a radar if you have a use case.
Yeah, good point. Yeah. Anyone else? There you go.
How tolerant is the image detection, right?
Right.
So could you take a photo of, like, say, an outside scene and a few, there's people in different spots and things like that. Would you still be able to detect based on it?
So first of all, the image that you're looking for needs to be flat. It's not looking for like shapes on there. It's looking for a flat image. I'm sure there's some processing involved that allows ARKit to detect partial matches, and I think I can show that. Let's try and restart that. If it doesn't crash, now it's crashed. I've had a precondition somewhere, and now it crashes. It's like, that's just what it happens. Okay, so I'm not, oh, there you go. I've been pointing at just half of the image, and seems like it was enough for it to detect the whole thing. Because it knows the physical size, it probably has detected the center, and it gives me the whole thing, which is pretty nice. I'm sure the more reference images you have specified, the more difficult it would be. I didn't check one interesting question, and that is how many reference images you can specify until the performance just drops, it becomes unacceptable. That I didn't try. But as you have seen, on a like average lighting conditions, half of the image was enough. Maybe it is just enough texture in here to detect. Maybe. There you go.
To experiment, just curve the paper a little bit and try.
I can try that. I'm pretty sure once the surface becomes not flat, it becomes much more difficult. Okay, pretty sure I was mirroring. Okay, so I'm.
Just tell us.
It's problematic, yeah. So once you curve the paper, it becomes more problematic. So I've curved it a little bit. Well, with this kind of curvature, it's okay. It really depends on what ARKit is actually looking for in the image. It may be reliable enough for simple curvature, but you can see how, it won't work all the time, effectively. Pictures are the best ones.
Which detail does it need in the image?
Now, that I don't know, to be honest. I've only been experimenting, I've only been collecting empirical data here. So, as you have seen, it's like half of the image was enough. By detail, do you mean like resolution of the image?
I mean, like how much does it need to find? Like if you took images of people's like body shape, would it then pick that up as being something you project onto?
So as I've said, I don't think that shapes would be something ARKit would be good at detecting. So I'm pretty sure it's looking for colors and maybe feature points. The implementation is not exposed anywhere in documentation or elsewhere, so I don't actually know how it works specifically. Though using Hopper might shed some light. But yeah, I'm pretty sure it'd be looking more like on a texture. So if you have a human wearing one kind of clothes and another kind of clothes, those would not be the same from ARKit's perspective.
Give it a go.
Sorry, what?
Give it a go.
I suppose, yeah. Anyone?
For the vertical plane detection, do you need better performance out of the front-facing camera on iPhone 10?
I didn't try that. I'm pretty sure front camera is not designed to work with that, simply because the true depth camera is designed for this kind of distance. So once we get true depth camera on the back, absolutely. For now, I'm pretty sure it's mostly designed for face anchors. Actually, it's possible that if you're using frontal camera, it just doesn't detect anything else other than face anchors. Maybe next year.
Have you had a chance to try the runtime image?
Try what, sorry?
The runtime. You said you can add to a set, or you can put the CG image as the.
Oh yeah. So as I mentioned, you can definitely specify a image in runtime. That's what I'm actually doing. Yes, you can pass CG image and the physical width. It will obviously take the aspect ratio of the CG image and calculate the physical height from that. Yep.
You actually can download from API.
You can. You definitely can. Well, I think, yeah, images are not code, so that should not be, that should be allowed as per App Store guidelines. So I don't think anything would be stopping you from doing that. Which is nice, actually, because I remember this friend of mine who's working in a similar field, and he was talking about like hundreds and thousands of different artworks. And I'm like, how do you manage that sort of complexity? But turns out he is actually doing that on the back end. And so I thought, well, you could, in theory, do that with ARKit as long as you somehow can isolate the set of reference images to like a particular location. Maybe you enter a museum and your backend maybe tells you what particular set of images to use, or even maybe you can download those images, but then like how many megabytes would that be? That would be the question.
Do you have control over the memory? Like if you download image on runtime, you have entire clear it out.
That's what I didn't try yet, as in how many images you can specify to the session until performance drops. But, well, it's not magical. I'm pretty sure. I wish it was, but I don't think it is. So I'm sure there's some limit. And I don't think it's above 1,000, maybe even 100. But don't know. Don't know, to be honest. Anyone else?
Thank you, Vlas.
Thank you.